Hello, this is Dr. Grande. Welcome to my video comparing significance to effect size using SPSS. As always, if you find this video to be helpful, please like it and subscribe to my channel. I certainly appreciate it. I have here in the SPSS data editor fictitious data that I'll be using for this example. I have an independent variable named treatment. It has two levels, psychodynamic and REBT, and a dependent variable, depression, which is a continuous variable measured at the, in this case, interval level, but a continuous variable could be measured at the interval or ratio level of measurement. So I'm going to conduct an ANOVA using these data. Now, of course, with just two groups, I could use a t-test, but for this example, I want to compare significance and effect size. So I'm going to perform an ANOVA here. So this will be analyze, general linear model, univariate, and for the dependent variable here in this text box to the right, I'm going to use depression, and for the fixed factor, I'm going to use treatment. Again, treatment just two levels, REBT and psychodynamic. So I'll click OK here, and I've added no options to this output, so this is default. And you can see we have here for treatment a significance level, probability value of 0.024. So we can interpret this as 2.4%. So this tells us that there is a 2.4% that we could have made this observation by random error alone if the null hypothesis were true. Now, oftentimes when we use a one-way ANOVA or other inferential statistics, we're trying to determine whether we can fail to reject or reject the null hypothesis that we're testing. So if the null hypothesis in this case were that the two groups were equal, that would be the null hypothesis. The REBT group and the psychodynamic group were equal as measured on that dependent variable depression. In this case, we would reject the null hypothesis. 0.024 is less than 5% or 0.05, which is often the alpha value we use in the social sciences. So we have the alpha value of 0.05, and we have the probability value given here by our output of 0.024. So setting the alpha and using the p-value to determine if the null hypothesis should be rejected or if we fail to reject it is useful. It's a useful way to use statistics. However, in some cases, like in this case, comparing measurements on a depression inventory, we don't know from hypothesis testing how important the difference is. We know there's a difference between the two groups, but we don't know how important it is. Simply rejecting the null hypothesis isn't enough to tell us that the difference is important. It just tells us that there is a low probability that the difference we observed occurred through random error. So now I'm going to go back to analyze, general linear model, univariate, and bring up that same univariate dialog, except this time under options I'm going to add estimates of effect size. I'm going to check this off under display, this display frame, click continue, click OK. So this is the same analysis that I conducted before, except now I have this additional statistic, partial eta squared. Now in the case of a one-way ANOVA, an ANOVA where you only have one independent variable, partial eta squared and eta squared are the same value. They're equal for a one-way ANOVA. The values would be different when you have more than one factor. So this partial eta squared value in this case is 0.106. And again, we could look at this as 10.6%. And this tells us the proportion of variance in the dependent variable. In this case, the dependent variable was depression. The proportion of variance is explained by group membership. So the amount of variance in the dependent variable explained by the independent variable. So this partial eta squared value is a measure of effect size. It tells us how important the difference between the two groups is. It's possible to have a statistically significant difference between two groups, but have the effect size be so low that it's not important or meaningful. It doesn't have a practical significance. It's also important to recognize that as sample sizes increase, it becomes very easy to find statistical significance. If you have thousands of samples, finding a statistically significant result wouldn't be surprising. Whether that result is important or not, we would look to the effect size to figure that out. The effect size also lets us compare the findings from one study to the findings of another, if both findings involve reporting the effect size, if we have the effect size available in both articles. Although even there, in that situation, when looking to make a comparison, we have to recognize that there are different types of effect sizes. Here we have partial eta squared, which for one Way ANOVA again is equal to eta squared. However, another popular effect size statistic is Cohen's d. Eta squared and partial eta squared are strengths of association. Again, looking at the proportion of variance in a dependent variable that's explained by group membership. Cohen's d is a standardized mean difference, and it's calculated by taking the mean of one group, subtracting the mean of the other group, and dividing that by the pooled standard deviation. Eta squared is calculated differently. In the case here with just one independent variable, we would take the sum of squares for the effect and divide it by the sum of squares total. So looking here, this would be 126.750, sum of squares for treatment, and that would be the sum of squares effect. And then for sum of squares total, we would use the corrected total, which is 1195.917. So moving quickly over to Excel, we have the sum of squares effect, and that would be sum of squares for that treatment variable in that output table in SPSS, and sum of squares total, again that would be the corrected total. So this would be 126.75, and for sum of squares total that was 1195.917. And here for this eta squared function, this would simply be equal sign sum of squares effect divided by sum of squares total. We get 0.1059. So moving back here to SPSS, partial eta squared here, so if I double click and we expand this, 0.1059. Now another area where you need to be careful with effect size is determining what's important. Again, if we look at significance, we look at the probability value, it's generally agreed upon that we use 5% in the social sciences as an alpha. It's not always the case, but it is a popular choice. Similarly, we have guidelines depending on what measure of effect size we're using. And we look at these as categorical. There's a small, medium, and large effect size. If we're talking about Cohen's d, a Cohen's d value of 0.8 or greater is considered large, 0.5 to 0.8 medium, and 0.2 to 0.5 as small. Eta squared in an ANOVA would be different. Large would be 0.14 or 14%, medium 6% to 14%, and small 1% to 6%. So as you conduct analyses and you perform various inferential statistics, keep in mind that significance, the p-value, and the effect size are different concepts. One's not better than the other. They're used for different purposes. So we test a null hypothesis using the significance level, and we determine how important a difference is using the effect size. I hope you found this video on significance and effect size in SPSS to be helpful. Thanks for watching.